I saw a short video here on the sampling distributions for differences between two population means, and we'll flip the board around and look at the distributions for differences between population proportions. So this concerns when we're talking about confidence intervals and hypothesis tests for differences between two population means and differences between two population proportions. So when we're talking about means, differences between two population means, we can see this is the relevant information. Okay? The unknown population means, right? We don't know what these are. This is what we're interested in finding something out about. We take two samples, right? One from the first population, we get a sample mean with a sample size 1, right? Sample mean from population 1, sample size 1, sample mean from population 2, sample size 2. Sometimes we will know the standard deviations of the population. Sometimes we will not, and we will need to substitute the sample standard deviations. So remember our conditions to use the standard normal distribution. Central limit theorem when we're talking about means. Here we have two samples. Now, if we're told that the population distributions are normal, we're good to go, right? But if we're not told that both population distributions are normal, we need those sample sizes to be larger than 30, or we need the standard deviations of the population to be known in order to use these techniques that we're going to use to come up with confidence intervals and hypothesis tests. Okay, so same conditions as before when we were doing one mean. Now we're looking at the difference between two means. So when those conditions are met, the difference between the two sample means, we're going to look at the sampling distribution, and this is going to be our sample statistic, right? The difference between the two sample means. That distribution is going to have a center at the hypothesis, the null hypothesis, that there is no difference between the two population means. We don't know what these numbers are, right? When we do a hypothesis test, we're going to assume that this number is 0 and that there is no difference between the two population means. But we don't know what these numbers are, right? These are unknown population means. But that's the center of our sampling distribution. And the standard deviation of that sampling distribution, which we have come to know as the standard error of the sampling distribution, if the population standard deviations are known, then it's going to take this form. If the population standard deviations are unknown, then we have to use the t distribution for our tests and confidence intervals, and this becomes the standard error. Right? Notice these are very similar, the only difference being the population standard deviations here as opposed to the sample standard deviations here. Okay. So we're concerned with creating confidence intervals and performing hypothesis tests for this difference between two means. So when we're talking about confidence intervals, again, two cases, right? If we know the population standard deviations, then this is going to be the form of our confidence interval. This is the center of our distribution, our point estimate, the difference between the two sample means. We use our familiar z critical values for whatever level of confidence we're interested in. And this is the standard error, which we just discussed. When sigma 1 and sigma 2 are known, this is going to be the standard deviation of the sampling distribution of this statistic. And that's what we're using here, right? We're saying this is the center of the distribution, and we're going out this in both directions, this many standard deviations of that sampling distribution, which we call the standard error. If those population standard deviations are unknown, then we're not using the standard normal distribution, we're using the t-distribution. And remember, the t-distribution is different for each sample size. So when you're talking about degrees of freedom in this case, you're going to take the lesser of the 1 minus either of the sample sizes, whichever is the lesser of these two values, n1 minus 1 or n2 minus 1, those being the sample sizes. And if that's the case, then this is the form of our confidence interval. Center being the same thing, right? The difference between the sample means. And then we're going out this many standard errors of the t-distribution's standard deviation, basically. All right, so confidence intervals sigma 1 and sigma 2 known, z critical values, standard error here. Sigma 1 and sigma 2 unknown, this is the form. We use t critical values and we substitute the sample standard deviations. For hypothesis tests, this comes into play when we're forming our test statistic in step 2, the step 2 of our hypothesis test, where we're gathering the data and coming up with our test statistic, the evidence phase. So once again, if the standard deviations are known, we're going to use a z test statistic and the standard normal distribution in step 3 to find our p-values. And we know the form of our z statistic, the estimate, again, minus the hypothesized value of the difference. And we're going to always, under the null hypothesis, say there is no difference between the two population means. So that value is going to be 0. Right? So point estimate minus hypothesized value over the standard error when sigmas are known. Or if we don't know, we use a t-test statistic, same numerator. Now the denominator is different according to that different standard error. Okay, so confidence intervals, sigma's known, this form, sigma's unknown, this form. For hypothesis tests, z statistics or t statistics. And that's the distribution. We'll do an example of each one of these in a future video. So now let's look at the difference between two population proportions. Here, sampling distribution, we're talking about difference between two population proportions. Now this is a little bit less complicated because it's always going to be a z statistic for hypothesis tests and a z critical value when we talk about confidence intervals. So here the relevant information, again, the unknown population proportions from population 1 and population 2. We take samples from those populations and come up with our sample proportions. P1 hat is the sample proportion from population 1 and its associated Q1, right? 1 minus that. Remember, these are binomial ideas, yes or no, success, not success. So there's only two possibilities when we're talking about proportions. We have a sample proportion from population 2 and its associated Q hat 2. Now, one thing that enters in here is something we call the pooled estimate. The pooled estimate is going to be the sum, I should put that here. The pooled estimate is going to be the number of successes, total number of successes, over the sum of the sample sizes. Right, so if you have two proportions, say 3 out of 10 and 4 out of 10, the pooled estimate is going to be 7 out of 20. Right, so the total number of successes out of both samples divided by the sum of the sample sizes. And that's going to be called P bar, and Q bar is going to be 1 minus P bar, just like the Q1 hat and 1 minus P1 hat, and the Q2 hat being 1 minus P2 hat. Okay, so that pooled estimate comes into play when we're talking about the standard error for hypothesis tests. All right, so total number of successes over the sum of the sample sizes, and Q hat being 1 minus that. All right, so again here, it's always a Z statistic, always a Z critical value. Now, very important here is the difference between, well, first let's look at the conditions, right? The statistic we're looking at now is this. The difference between the sample proportions, that's the sample statistic that we come up with from our samples. Now that's going to have a normal distribution if these conditions are met. These four conditions, P hat 1 times the first sample size, P hat 2 times the second sample size, and the associated Qs, all of these have to be more than 5 for us to use these techniques, again, for us to use a standard normal distribution and be able to rely on our results. Okay, so these are the conditions. The sampling distribution is going to have a center at the unknown difference between the population proportions. So P1 minus P2 is going to be the mean of the sampling distribution, right? Those are unknown, remember, just like the unknown population means. The difference between those two unknown means was the center of the sampling distribution for the difference between two means. This is the mean of the sampling distribution for the difference between two sampling proportions. And the standard deviation of that sampling distribution is going to take one of these two forms, depending on if you're performing a hypothesis test or you're creating a confidence interval. Right? So if you're doing a hypothesis test, that's where that pooled estimate comes in, here and here in these numerators over the two sample sizes. If you're creating a confidence interval, then you're going to use the P hat 1 and Q hat 1 here, and the P hat 2 and Q hat 2 here. So very important difference here. For hypothesis tests, you're going to use this in your Z test statistic. For confidence intervals, you're going to use this as your standard error. And that's explained more fully over here. For a confidence interval, the center of our interval is the difference between our sample proportions. Z criticals, again, we know our Z criticals hopefully at this point, and this is the standard error that we use for confidence intervals. So again, center, plus and minus, this many standard errors. This part is the margin of error. This is the point estimate or the center. And for hypothesis tests, same form, our point estimate minus the hypothesized difference of 0. And here we're using this form of the standard error, like we explained over here. Okay. Hypothesis tests, Z-test statistic, always P bar, Q bar being used in the denominator of the fraction. Confidence intervals, always a Z critical, and you're using the P hats and the Q hats. All right, and we will do examples of all of these in future videos.